Hi, and welcome to a video on the second derivative test. This video is just going to give the basic concept of how the second derivative test works and why, and it's going to be connected with the visuals of the second derivative test. So we won't be doing an example, but you'll see why this works. So first of all, I've got the first and second instance. So if you have the first derivative equal to 0, that is a critical number, right? And if the second derivative is less than 0, then your function is going to have a local maximum at x equals c. So let's just draw a picture of a portion of a function where these two things are happening. Now, I'm kind of drawing the second part of this first. So what I've drawn here is the portion where the second derivative is less than 0. And remember, when your second derivative is less than 0, you have a function that is concave down. So I've just drawn something that is concave down, and that satisfies this requirement. Now, if the first derivative is 0, that means the tangent to the function, so this is our function, the tangent line has to be horizontal, or the slope has to be 0. So this is what would represent a horizontal tangent line, or the first derivative of your function equaling 0. And actually, I should replace that x with a c because we're looking at one specific value c, and that would be right here. Okay, so if these two things happen simultaneously, if your second derivative is less than 0 and your first derivative equals 0, at this x equals c value, you are going to have a maximum. Okay, and you can see from our picture that we do have a maximum near that x value of c if those two things happen simultaneously. All right, the flip side of that is if the first derivative equals 0 and the second derivative is positive. So we're going to start with this time, and if the second derivative is positive, we're going to have a function that is concave up. So this is our function, and our second derivative is greater than 0, and when that second derivative is greater than 0, we have a concave up graph near that value. And if our first derivative is also equal to 0, right, we're looking at where our f prime equals 0, or f prime at c equals 0, we have right here this c value where that derivative equals 0 is going to be the x value equal to c where we have a minimum. Okay, so when you're looking at the second derivative test, this is a very fast, efficient way to quickly test a point where you know you've got a derivative equals 0, and you want to know if that first derivative x value produces a max or min. You can just plug it into the second derivative and see if you get a positive or a negative. So to summarize, here's what's going on. You have a maximum at c when the first derivative at c equals 0 and the second derivative at c is less than 0. Okay? You're going to have a minimum at c when f prime at c equals 0 and the second derivative at c is greater than 0. Okay, make sure this goes into your conjecture notebooks so that you can use it and have it for quick reference. I hope this was helpful. Thanks for watching.